Hey everybody, this is Mr. Fowler from the block. This is podcast 2.1. We're going to talk about electrons and how they fill. Get a periodic table right now. Yep, right now. If you're not going to get a periodic table, you're going to have to write a periodic table. Write your own about 10 times. Okay? You need to get a periodic table. Get one now. Okay, let's get started. All right, atoms come with electrons, but it's helpful to think of atoms as adding electrons one at a time. This way we know where they go. Okay? This means we need a filling order. This is called the Aufbau principle. And the Aufbau principle states that we add electrons to the lowest energy level first. Why the lowest energy? Because that is more stable. You absolutely need to know that lower energy is more stable. Low energy equals more stable. High energy, think of a high energy storm that will knock your house down. That's a tornado. Okay? Periodic table shows this order. Now I'm going to hop to something else to show this order. Alt tab. Where's my tab button? Boom. There we go. So the filling order of electrons goes, oh come on, move down a little bit. Goes from left to right, from number 1 all the way down to 86. It goes beyond that. That'll do. So no, go away. No. And it goes across this way. Okay. So I start off with this. This is the first row. These guys right here are the S block, all the way down inclusive. This is S. This is S. This is P. This is D. Oh, I can highlight with this, can I? So here's S. Whee! Yellow. Here is P. Well, green. D is blue. Whee! And then F, it'll let me show you, is, oh, I don't know, whatever color this is. Okay, there are your blocks. So if you have a periodic table, go ahead and color those in and label them however it makes it work for you. Okay? So the filling order is starting up here. So I start right here. This is the first row. So this will start with 1. This is the S block. S. And I have 1, 2 electrons, 1 S2. Okay? So let's just say I'm going to stop at carbon, okay? So we'll do carbon equals. This is the second row. That means I put a coefficient of 2. S block. S. 1, 2, 2. I'm all out of S's, right? Now I'm on to P. Still the second row, right? Still the second row. P block, and I have 1, 2. 1 S2, 2 S2, 2 P2. Okay? So let's do another one. All right, I'll erase this. Let's do titanium. Titanium. Okay, so titanium has 22 electrons. So I'm going to start out here. Whee! No, it's going to start just like carbon. First row, S block, 2. Second row, S block, 2. Boop, boop. Still in the second row, 1, 2, 3, 4, 5, 6. Second row, now this is the P block. Remember, these are the P's? P block, 6. I'm going to go here, up, new row. Third row, back to the S block. S block, 2 of them. Boop, boop. Still the third row. P block, 1, 2, 3, 4, 5, 6. 6. Fourth row, S block, 2. Boop. Now, this is the D block. Now, you would think this would be 4D. No, 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 no. So, this group, which you think would be 4D, this whole group right here, you need to think of it as being bumped up 1. It's a core electron. We'll talk a little more about it in class. But instead of being on a 4, this is a 3. So, all of your Ds are bumped up 1 level higher than the periodic table says. Okay? So, this is going to be a 3D. Titanium is 3D2. And there's titanium. All right? So let's go back to the original one. Oh, tabby. Yay. All right? So we now know where these blocks are. And how many columns are in the S block? So if you look at your periodic table, we learned that the S block has 2 columns, right? So how many electrons fit in the S block? 2. Okay? Because that's how many columns you have. How is 3S different from 1S? Third row. How many electrons are in the P, D, F block? P6 is the max, D10 is the max, F14 is the max, and what tells us? The number of columns. Okay. Hey, I did carbon. So let's do rubidium and samarium. Rubidium, where are you, rubidium? Rubidium is number 37. Hop back to my Alt tab. Rubidium and samarium are the ones that I said I would do. I'll change my color a little bit just because I think that's fun. Rubidium is right here. I know that's the same color. So rubidium has to go through all of this. Notice how it's going to be a lot of repetition, so it's going to be exactly the same up to titanium. So this first row is going to be 1s, right? 2. Next row, 2s, 2 columns. Here's 1, here's 2. Next part is 2 p block. How do you know that? Oh, I labeled it. 6. Uh-oh, next row, 3 s, 2. Next part, still third row, P block, 6. Now I have to stop here, right? This is 4. You have to be able to see that break. 4, S, 2. Now I have scandium through zinc. Now remember, this is the weird one. It's not 4D, it's 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D10. And then I'm back to the P block. Remember, it was not bumped, so I'm back to 4P. 1, 2, 3, 4, 5, 6. 6. Then I'm down to the 5th row. S. Oh, but it's only one of them, so rubidium is this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, not 16. I said 10. I just wrote an ugly 10. 4p6, 5s1. That's rubidium. Yay! Now if I did samarium, which is number 62, I'm going to continue from there. So samarium, you can recopy it if you want to. But I got to rubidium. So here's rubidium. Samarium's all the way down here. Okay? So samarium is number 62. So what I have to do is I have to get from 37 through 54, 55, 56, 57, and then I have to do 58, 59, and I'm going to stop right here. Okay? So I have to finish my 5s2s, okay? So I'm gonna change my 5s1. So change my 5s1. I'll change my color too. So my 5s1 is gone. Bam! Everything up there is the same. 5s2, that got me here. Then I have, what would my D be? It's not 5. Bumped up 1. 4D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have 5P6. Right? 6s2. 6th row, S block 2. Then I have 5d1, gets me to 57. Then I get right here. Now, I can tell you, this one's bumped up 2 or whatever. But if you just remember, this is 4 and this is 5. 4f. 1, 2, 3, 4, 5. 4f. Now, if you go, man, this is crazy. This is so much. You're right. We need to practice the heck out of this one. And we will. So, just know. So we did all of it. Samarium's a nightmare, right? There's a lot of repetition. I didn't even do it twice. So a way was developed to show the outer electrons only. Valence electron, valence is outer. I'm going to add outer. S and P, and the other blocks are core. Core notation is synonymous with noble gas notation. So let's take a look. Calcium, both. So calcium, I'm going to write this one quickly. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's calcium. Now the core notation, or noble gas notation, takes us to the first noble gas. The noble gases are the ones all the way on the right-hand side. So the noble gases are your heliums, your neons, your argons, and everything that goes down the far right-hand side. They all end in P6. Okay? So the preceding noble gas for calcium is argon. So instead of writing that, I simply write argon in brackets. So that takes me up to number 18. So all I have to worry about is number 19 and number 20. So number 19 and number 20, pull that periodic table back up there, Alt tab. So argon is my preceding noble gas, right? 19 and 20 is just 4s2. Alt tab. 4s2. That's much easier, isn't it? Yeah. dB, noble gas only. dB is number 105, doggies. Okay? So the preceding noble gas for number 105 is number 86, which is radon. Then I have to start with 87 and 88, which is 7th row, S block 2. Then I have 6th row, D block 1. And that gets me 89. Then 90 to 105, 90 to 103 would be 5F14. And then notice, did you see where that came from? I had to sneak down to that F block. There's a little line on your periodic table that gets you there. And then 104 and 105 would go back to, I got to recombine this. So my overall D value is going to be 3. See, I'm the 3rd one in the D block. 63. We'll get a bunch of practice with those. Positive ions lose valence electrons, and negative ions gain valence electrons. Aluminum, lost 3. Neon, no charge. But if I wrote the electron configuration of aluminum, aluminum has 13 electrons, so it would, if it lost 3, it would have 10. Well, neon has no charge, and neon has 10 electrons. The periodic table shows you this, okay? So aluminum plus 3 and neon have the same number of electrons. That means isoelectronic. Same number of electrons. So S negative 2 is isoelectronic with what positive ions? Let's use Alt Tab. Okay, so S negative 2 would get me to 18, right? So what positive ions would have 18? Well, a positive ion would lose it, so K positive would have 19 turned to 18 electrons. Hey, that's like argon. Calcium plus 2 would have 20 turned to 18 electrons. Okay? So that's how we get started. Alt Tab again. I'm reading my screen upside down when I do this. So there are a couple of questions. Oh man, I got rid of this. I hope you didn't copy that down, because I saved it and got rid of it. Damn. A few more rules about electron. Hund's rule. Electrons can reside in bundles of up to 2 called orbitals. So bundles of 2 electrons. And these bundles are orbitals. An orbital for us is a box, and you'll see that in a minute. Orbitals of equal energy will put 1 electron in each before any orbital gets full. This is Hund's rule. Helping Hund. Another way to look at it is inspired by a real science at the University of Illinois. And I'll just talk about this one in class. But if you see it, you'll chuckle and wonder. Oh no, don't. Oh! There's a part 2. Watch the part 2. Stinky computer.